we're live,
Selena,
guys. Let's start.
super. All right. Welcome, everybody. I would
Hello,
like
guys.
to start with a quote. Yes. Uh, we have elected to put our money and faith in a mathematical framework that is free of politics and human error. My name is Tejas, and this is Lokesh, and we'll be giving you an introduction to an awesome ecosystem called Polkadot, which is a blockchain, and the framework that it uses, which is called Substrate. So, yeah, Lokesh.
Yeah. So, the multi-chain vision for Web3 starts here and now. And having said this, let's move on to how Polkadot and Substrate palettes work and how Polkadot is going to play a key role in seeing this multi-chain vision. So, yeah, topics that we're going to cover today. Yeah,
Blockchain,
Polkadot
Substrate.
and our own very own Polkadot community in India. So,
Yes.
yeah, like they just
So
saying. So they just
yes. So this is the same code that I was referring to, and this is by a very famous crypto investor called Tyler Winklevoss. You can remember him from, or you can refer to the movie Social Network, but he's the real deal. So yes, this is something that we really believe in, and we believe that Web3 will change the world in the next 5 to 10 years. So yes.
yeah. So
All right.
blockchain is in very simple terms is just a decentralized trustless economy. So we're removing the centralized picture of it, and we all of it is managed via code, smart contracts, or pre-written code, defined laws. So that is what simple blockchain is. Yeah,
So yes, like Lokesh mentioned, before that, I'll just tell you about the index. Like first, we'll be giving you an overview of blockchain. Then we'll move on to Polkadot. Then explain the framework that Polkadot is using, and then we'll conclude. So this is just a basic overview of blockchain. So basically, blockchain is a distributed ledger. Uh, by a distributed ledger, it's basically database distributed across continents, if you want to visualize it like that. So there is no central authority. So the authority is the people. That is what makes a blockchain. And all of these blocks have their own set of transactions within them. And these blocks are linked together in an ordered fashion. So hence the name blockchain or chain of blocks, right? So every block has its own called which is a hash, and that hash is or that hash makes the block unique within the chain of blocks, right? And they are connected to each other in an ordered fashion, like I mentioned previously. So this is like a basic introduction to blockchain.
yeah, and yeah. Moving on. So basically, what is Polkadot? It's a blockchain of its own. The model, the way Polkadot works is it has its relay chain, which is the main piece or the core network, and there are other blockchains that can connect and connect to this relay chain, and it also acts as a bridge to communicate between these chains. Yeah, that is a very brief description of a Polkadot, and let's just look into in depth of how Polkadot has architected the system and its functionalities that it offer.
Yes. So like Lokesh mentioned, this is Polkadot is in itself quite unique because it gives way to integrate multiple chains, right? So you can create your own blockchain and connect it to the Polkadot ecosystem. So like he mentioned, the relay chain, which is the main chain, and you have like sub chains, or also called as para chains, that connect to the main relay chain, and they function accordingly. So, so yes, this is the introduction to
Yeah.
yes.
So, like everybody knows, that blockchain works on something called consensus. And what is consensus? Consensus is, in simple terms, is basically a ground level where multiple people uh, can come to agreement with. right? That is what is consensus. Now on the blockchain system, how do we favor this? We have two types that Polkadot particularly works with. Most of you must be familiar with proof of work that Bitcoin uses, and Ethereum was also using proof of work until they moved to POS, so proof of stake. And in proof of stake, it's a simple consensus mechanism. Basically, to achieve block finality, the validator needs to stake a certain number of coins, and he validates that piece of transaction, right? So that is how proof of stake is, and Polkadot in detail uses POS and also NPOS, nominated proof of stake. But more on that on the further slides. Yeah, the other one is they just yeah.
Yes, I know the name is funny, but it has a big functionality within the Polkadot ecosystem. So basically, Grandpa is also a consensus mechanism, which helps in finalizing the transaction in a block. So, for example, there is broadcasting of a transaction and there is finalization of a transaction. So, as you can see, Grandpa is the one which finalizes the transaction, and
Mhm. But hold on, they just
yeah,
yeah.
Lokesh, go on.
But see, looking at the slide, no, the just looking at slide and reading the lines, I see Grandpa to be like an ethereal, scary being. It's ghost. What is ghost here? Like, why is Grandpa based off of ghost?
So it's a scary grandpa. All right, I'm kidding. Okay, so basically, Ghost Protocol means that the broadcasting is not happening there. So when you're finalizing the transaction, instead of broadcasting, it is a silent transaction, right? So for let's say I and Lokesh come to a consensus over a specific transaction, and that is not being broadcasted to the other nodes or to the other people on the chain. So other than the transaction that is broadcasted, which needs to be, or in other way, which needs to be broadcasted throughout the chain for for the validators to look into. So this is what the Ghost protocol means by Grandpa. So everything is done like silently. The finalization of a transaction is done silently, in simple words.
Got it. Makes more sense technically. Yeah.
Uh, oh
So
my god.
yeah, moving on. What are the advantages of Polkadot? Right.
Yep.
So it has true interoperability. Like I said, now what is interoperability? So this is basically a concept where two people living outside or living in two different ecosystems can communicate with each other. Like one stay in another place and I want to communicate to another place, so I establish a video call or call where I can still connect to them. Similarly, now blockchains are on multiple levels, right? You have an Ethereum stack, you have Solana, you have Bitcoin, you have Stacks, you have Polygon, you have Near protocol. So there are so many blockchains now. How I mean, people can live inside the blockchain, data can live inside there, but we want to share data across chains or even across parachains. Now how is that possible? That is where Polkadot has this protocol called xcm and xcmp, which is a messaging protocol that allows data sharing and asset sharing between parachains within Polkadot ecosystem. There is also a layer for EVM to communicate with the Ethereum contracts. So this is one of the major advantages that Polkadot offers you out of the box.
Yes. So interoperability means like two chains are friends with each other through a protocol called XC.
Yeah.
In simple words. So easy blockchain innovation. Like we said in the start, that there is a framework called Substrate. You can just fire up a blockchain using Substrate, and literally a blockchain, not like smart contracts. You can create your own blockchain from scratch if you want to, but there is also a way where you can just add little functionalities and also uh, uh, bring a blockchain to fruition. So that also can be very easily done using Substrate with like three commands, I guess, literally.
Yeah, that's I think that's pretty interesting if you just want to start your own chain and you can do it like under half an hour, right? That's pretty interesting.
So less than that, bro.
Yeah. Nice. So yeah, but having said that, you need to have a nice system. So there are certain specifications, minimum specifications that Polkadot has mentioned in their website. You can go and check it out at polkadot.network, where these are the minimum system requirements to run as a single node, and how you want to run it as a validator, as a nominator. So there are certain specifications. But yeah, coming to security, so everybody, while building your chain or you're building a D app or your DAO of your own, you always need to face the problem for security, right? You need to make sure that your chain is secure, there are no external threats, people can't come and penetrate and take out data, or there's no data leaks, or there are several attacks, right, that we want to avoid. Now, how is Polkadot telling you that it's more secure? So the reason is because the main relay chain that we know has a highly secure system, and it has a council member. I mean, a council where you have group of members who are actively making sure that the security is being updated. And all of you must already know that Polkadot is built based on Substrate, which is based off of Rust. When it comes to terms of code, Rust already provides you high scalability for security. It's highly secure. Second thing about Polkadot is whatever security that the relay chain offers, you as a parachain, when you connect to the relay chain, you're offered the same security. The security is being shared, so you will also come under its umbrella, make so this giving you the, I mean, a safe or secure feeling that okay, the relay chain is a bigger chain, it is more secure, it has a lot of security protocols, and you are under the same umbrella and you have the same functionalities to prevent any sort of security attacks, or to make sure that you have a stable chain running. So as a beginning at an app, you don't really need to focus on how you want to improve in security. Yeah.
Yep. Uh, what do you mean by economic and transactional scalability? Basically, you have a common set of validators, which validate the transactions throughout multiple chains. So it's economically and transactionally scalable. You don't need a separate set of validators for every chain, right? So that makes it a more trusted ground, or a more trusted ground, source of truth. So you have validators from within the Polkadot ecosystem, which are validating transactions on multiple chains. So that makes it economically and transactionally quite scalable. Uh, Not
Yeah.
repeating more validators.
Yes. And see, when it comes to energy consumption, by definition of the consensus POS, you save a lot of energy, computational energy that POW normally has. So you save a lot of energy there. And now Polkadot also works on this nominated proof of stake. Basically, you have a group of nominators who select their leader using the POS consensus, and a validator is finally chosen, and this validator and everybody in the network, who based off whoever they are, they stake their money, and to achieve block finality. So yeah, you already save a lot of energy consumption when it comes to electricity, and POS running on a system is comparatively less memory hungry when compared to other consensus that provide. Yeah.
True. I would like to add to the POS part. So
Mhm.
somewhere I had read that now, like before the merge, Ethereum merge, I think Ethereum was using POW, proof of work transaction, was taking a household. So I'm not sure whether that is completely true, but that's where I read.
Okay.
So now the proof of stake, so you get that energy efficiency like from the beginning. So coming down to user driven governance, so the user has all the power on Polkadot. That's what it means. Like whatever uh, the set of rules is set by the user, and that's how the ecosystem in Polkadot and the other chains are governed. So
True.
yes.
So these are some spectacular features, or like you can say unique features that Polkadot offers. When you see the latest change, Ethereum has changed the world with smart contracts. Now, Polkadot as an ecosystem, it not only lets you build smart contract, it also builds let you build your own blockchain, your own node, and your own set of nodes. And these features assist everybody at an open box model. You're given a complete whole set for production for your DApp or your DAO. So yeah, these are the main things that we would like to use Polkadot for. And another thing I think we just should add is about the gas fee, right? They just
Mhm.
Polkadot is it's in early stages, and when compared to Bitcoin or Ethereum, your gas is pretty low, and also transaction speed. Your block times are around 6 seconds. So yeah, that's pretty fast if you consider the current existing chains. Yeah.
True.
So yeah,
So this is how, or this is a visual representation of the Polkadot main chain. Okay, so you can, so the relay chain means the main chain, and this is the Polkadot ecosystem in which multiple chains are connected. So we can just go back and forth, two
yeah,
slides. So the first thing that you see, focus on the pink part. So that is the relay chain. Okay, relay chain, the main Polkadot chain. Now can you go back, Lokesh? You
yeah,
see the silver, right, or the gray ring. So that is your main chain. Okay,
yes, yeah,
and yeah, can you go back to that slide? Okay, now the parachains. The parachains are the chains that are built with the substrate node template. Okay, um, huh. uh, can you see?
yeah, bees,
Can you see those pink bars?
yeah,
So
yeah,
those are your parachains or your individual substrate chains, which have their own set of functionalities. And
yeah,
if you want, you can create your own chain like this. Uh, parathreads parathreads are basically individual nodes within a substrate ecosystem or within a substrate chain. So those
yeah,
are
within your parachain, right?
within your parachain. Yes,
Connected to your parachain. So yeah,
yes. And bridges. So basically, bridges are the things that connect each chain to each, connect all the chains with each other.
yeah.
It's like interoperability.
So there's no bridge here to depict, but basically I think we can picture it like this. So bridge is something that allows communication between multiple parachains. They have come to a mutual consent, and they have followed the protocol that Polkadot offers to enable data sharing or asset sharing between their two parachains.
Yep.
Yeah,
Yes. Yeah. So this is the main thing powering the Polkadot network. So it's uh, dictated by three things. One is governance, staking, and bonding. Yeah, Lokesh.
yeah. So when it comes to governance, right, there are a council, there's a Polkadot council which holds authority to a certain percentage of the chain, and every year there's a different update to that percentage. But basically, you can elect your governors, and once you are like good in the chain, you become a governance. So what does governance do here? So they cast a vote. They cast a vote for all of the changes that the network needs to undergo, or something that needs to be implemented, maybe an focus upgrade per se, and anything the network wants to. The network rewards the tokens that are being minted every year. So those certain activities, and also identifying malicious nodes on the network, and malicious say account IDs that have data that is incorrect or fault with the distributed ledger. And yeah, so we can pass a motion to remove such people. And the governance protocol, I mean the governance council and its protocol is in such a manner that is connected to your NPOS, so that all these people in governance are staking certain amount of funds which cannot be spent. So their decisions also matters a lot, right? And they cannot go wrong. uh, so even if it is not wrong, it depends on the majority consensus based on inputs. So yeah.
And one more thing about the forkless upgrades that you mentioned, Lokesh.
Hmm.
So forkless upgrades, it's a really unique feature of Polkadot. So you can upgrade your chain without stopping it. So it's not like a hard fork that you do on other chains, but in Polkadot or in a substrate chain, you can directly upgrade your Polkadot. Directly upgrade your substrate chain without even stopping it, and all the migration will be done within that forkless upgrade. So that is a really cool feature that uh, you can use as you go along, uh, uh, building your chain.
Yeah.
So the second thing is staking. Staking is basically how the ecosystem is run. So basically, you stake some money, you validate your transaction, and the advantage or the security that staking offers is that when you stake some money, or the good क्या कहते हैं, good nodes, they are rewarded, while
Yeah.
the bad actors, as you can see, they are penalized for
Yeah.
any kind of malicious activity.
Correct. Because you have to initially when you're staking, the money is locked and that cannot be spent. So you'll need to make sure you're genuine and you're following the compliant
Yes.
rules. Yeah. So bonding is a feature that Polkadot uses to make sure that so how are parachains connecting to Polkadot or the relay chain? So let's understand this first. Moving on to before moving on to bonding, a relay chain has 100 slots. So that is the total number of slots that a relay chain has, and a chain that wants to connect to the relay chain has to apply or propose that they want to get a slot, and you win the slot via auction. So it's a model of an auction. So the highest bidder wins the slot eventually, and so again, once you win the auction, the slot is contractual based on a lease for a few years, or depending on how long you've been approved. And yeah, once that period is over, you're out. So when in this certain model, so Polkadot offers bonding where to make sure that if a parachain is outdated or not using, I mean, is not useful for the ecosystem or something, they can still remove that bonded contract and or the parachain by removing the tokens that were initially deposited. So yeah, so the make it, so by doing this, we make sure that the ecosystem is active and there is usable content or usable change that are always active and giving opportunities for better change. Yeah.
Yes. So these are some of the chains that are connected to the Polkadot network, as you can see. So these are one of the main chains and quite famous chains. One is called Akala, Chainx, Edgeware, and Darwinia. Um, all of these are built on Substrate, and they have their own functionalities. So
Yeah.
you can check out, and there are like much more chains connected to the Polkadot network, which you can see on Polka
But
project.
Tejas, we've been saying that Polkadot is so good and Substrate is so good as a framework and all that. But I mean, in real life, how many chains do we really have that has adopted Polkadot and solving real life problems?
Well, Logesh, there are actually more than 100 chains connected to Polkadot now. We have only shown four here at the moment. So
Mhm.
yes, so there are quite a lot of chains out there, which are functioning really well on the Polkadot ecosystem and growing as we speak. So which you can check on polkaproject.com again.
Great, cool. So yeah, we are like, I mean, isn't this already overwhelming? Like just the
No,
theory part of it?
don't worry, there is more to come.
Yeah, sure. So, Substrate, like I mentioned, it's a framework for building Polkadot-based blockchains, and it makes your life much easier when you want to start off building dApps or DAO using in the Polkadot ecosystem, right? And you can always visit this link. Substrate.io has clear documentation and tutorials on how to get started with Polkadot and Rust, and yeah, basically everything. Yeah. So, coming to how Substrate operates. So, like I said, it's a framework. I mean, it's also a software development kit, which basically has all the important functionalities that a blockchain would require, like consensus. It has palettes. It's called frame palettes. Basically, it's from the frame ecosystem that Polkadot is maintaining, and they have a lot of palettes that are useful for developers. For example, you want to build your own custom token, so you can use palette assets, which has functionalities for you to build a custom token, and they all follow a certain standard, right? Similarly, now you want to build an NFT marketplace. You have palette unique, which lets you build unique assets. So NFT is a unique asset, right? So that's how frame supports with palettes. And also you also have all the consensus mechanisms that you can choose, grandpa and babe, and aura. And you can also, like, if you choose to want to develop your own consensus, you can free to do so. And it's a very simple, uh, like, modular framework, to be honest, having worked on it continuously. And most of the things are like plug and play. You can change a lot of things. You can change your own consensus. You write your own palette. You say you don't want to use the custom palette that say palette unique. You don't want to use that. You want to develop your own palette of things, of certain functionalities. You can do that. And you want to share, say you built a blockchain, you built a palette, but say your palette can be open sourced, and you can share only that palette. So that is also can be done. So in terms of a framework, it's very modular, and all of the functionalities that you want, it's all plug and play, and you can easily find all of this in substrate.io and substrate.dev, where you have a marketplace, and you can go and look for, there are like 50 plus palettes and functionalities that you can use, right? When it comes to like why substrate over other frameworks, right? Whatever is there in the market for Solidity, Truffle, or the Solana. The thing is, like I said, one major thing is it's flexible because it's modular, and second, it's an open framework. It's open source; anybody can use it, and it has the interoperable feature which Polkadot offers via XCM, and it's out of the box. All you need to do is import the palette XCM, apply it to your code, and you're done. Like, you can start sharing data and asset transfer. Yeah, and it's future proof because Polkadot has a huge dev team that is constantly developing this, and there are monthly releases for every every update, and yeah.
So yes, as you can see, that is the link to the Substrate node starter kit. So that is a GitHub repository which you can clone and start your node on your local system. So there are some prerequisites before you do that. So you need Rust first of all, and since the entire ecosystem is built on Rust, and you need Wasm also installed on your PC. So you need there is a guide also before you start hacking the node template. So you follow that guide. Once everything is installed, downloaded and installed, you can start the substrate node locally, and make um, initial transactions probably. So yeah.
So yeah, so moving on, I just want to explain the folder structure before I go into the code. But yeah, as a brief, you have three main folders. You have the node folder, palettes, and runtime. Let me just give you a brief explanation of what it is. So a definition. So the node folder has a set of logic or configuration that is for your individual node to start. It's basically your main.rs file. So what is main dot? So is simply main file, basically like your Java main or your Python main file, main.py. So similar to that. Now, what are palettes? So like I've been using this keyword palettes overall through this throughout this presentation. So palettes are basically libraries, you could say, or a group of modules that hold logic of what you want to build. And moving on, the third folder is runtime, and a runtime basically is a place where you defined all of the palettes that you want to use for a particular runtime. Like, for example, you can have a runtime that might have only NFT, and another runtime that has both a tokenization of your own custom token as well as an NFT marketplace, right? So you can define multiple runtimes, and these runtime. So how are this linked? Palettes are defined at runtime. Runtime is then defined to node, and node is the one that you invoke by the start command. So this is the flow of how these are connected. So yeah, so let's look at the code now. How are these things working? So I have just opened substrate.playground. So if you are not, I mean, if this is too confusing, all you need to do is go to substrate playground. Yeah, once you're here, you can, so like I said, substrate provides you the template, right? You can use their online thing. So say you don't want to use on a system, you can use their online dockerized ecosystem for the node and how we start. So about the front end template, we're not going to explain in detail, but for those who are curious about it, yes, you can integrate your blockchain with front end apps, and you have a library for that. And even there's a front end template which makes life easier on, which is already integrated. So you just need to figure out how the integration is happening and learn on your own. But yeah, you can launch a playground here. But prior to this, I also want to show you the node template repo. So on GitHub, you can find the substrate node template repo. You can just search for it, and you can find this main repo. So here, this is the, like I said in the presentation, the three main folders that you will have to know is the node, the palettes, and the runtime. These are the three main folders that one has to know before starting Polkadot, or like before starting on Substrate. And yeah, like I said, these palettes are defined at defined at runtime. And this palettes, you build the logic inside the palettes, and then it's defined or instantiated in runtime. And this runtime is in turn connected to the node, right? So let's look at this in detail with the code. But before moving on, you can see how to get started. So you can run it on your own system by installing the prior things. You can always check out substrate.dev, and there are a lot of tutorials that you can follow. And yeah, but this is the command for all Rust projects that you use is cargo. Cargo is the manager for Rust, and you can start your own inside your node. But we're not going to do that. We'll directly use Substrate Playground that offers us a running node that is Dockerized, right? And you have a set of rules as well as that you can follow. So you can read about the template structure. How is this template going to be useful? Because now if I want to build our own chain, like we mentioned earlier in the presentation, just to start your own node is very simple. All you have to do is clone this repo. I mean, start use I mean install all your dependencies, and then you can just start it with this command, and you're I mean, you're ready to go. But now inside the palace is where you start writing your custom logic. So it's as simple as that. So the main thing that you need to understand when coming to such big code bases is how are the folders and which folder works for what. So yeah, they have written a detailed description of how it is. So like I said, it is the node, the runtime, and the palettes folder. So yeah, I've given you a brief description of how these are. But yeah, let's just get onto the code and see how it is. So if you observe, so let us forget all these things. Let me just close all this. Let's stop all this. So yeah, so I'm just gonna show you the node folder at the moment. If you see, it has a source folder, and like any Rust project, it's basically a Rust project on its own. So every the node folder has a main.rs file, which has a function main. This is the main point of execution. Now similarly, the palettes folder has multiple palettes. Now palette template is the name of the palette, and inside which it has another source. And again, you have a cargo.toml. So this is another cargo project or a Rust project. Now, how are even the runtime is similar. Inside runtime, you'll find a source, you'll find another cargo.toml, and you'll basically it's another project. So a question might arise now: how can a single template have multiple projects in it running together, and how am I going to even start it? So so in Rust, you have something called as workspaces, right? Cargo can manage its workspaces. So here you define the members of a workspace, because each of these folders are a cargo project on its own. So you define which is your workspace, and only one of these workspace will have a main.rs file. Like I mentioned, it's our node. Our node has the main.rs file, which will invoke the entire project, thereby communicating with all these folders. Like I said, palettes is I mean, I'm reiterating, pallets is connected to the defined at runtime. Runtime is then used into node, right? So that's how it is. So if you see your node folder, like coming to the main lib.rs file, you have chain spec, RPC, and service. So let's not get into too much detail with this, because our scope of explanation today is about substrate palettes. But a brief thing is, these are all your configurations. So these are like your environment configurations, you could say, or your node configurations, your node name, your node version, your definition, and what development are you going to use. You have basically, you have a local testnet, you have development environment, you can connect to the Polkadot ecosystem on Kusama as well. So again, what is Kusama? Just a brief is, Kusama is the test environment for Polkadot. So before you put your parachain onto the relay chain directly, Polkadot offers you Kusama, which where you can Kusama also has a relay chain where you connect your parachain and you test all the working of your parachain. You can run metric tests and you can see the entire functionality. And Kusama also has its own network. So how in real life, if it's connected to the real I mean relay chain, how it's going to function, right? So that's another plus point of Polkadot. Yeah. Moving on, like I said,
So,
so these are all
Ramesh,
environments that we are running. Yeah, yeah, there is.
uh, sorry to interrupt. So, I do have a question about palettes. So,
Mhm.
can you not have palettes inside the substrate uh, ecosystem? Can it run without palettes?
So yeah, you can run. So now see, for example, this palette has only one palette template, which is basically a dummy file, but or the template code that Substrate is providing. You not necessarily need a palette, because at runtime, like I said, your palettes are defined at runtime. If you come into runtime source lib.rs file, you can see something called construct runtime. So construct runtime is where you define your palettes that are required. Now here, if you have, now my template palette is connected here or defined here, saying that palette template is equivalent to my palette template, which I have implemented here. So in Rust is the similar implement function for your runtime, and you are implemented the event, right? So if you want to remove this also, you can remove this palette, and you can just use the base palettes. So like I mentioned, these are all your frame system palettes. So these are the minimum number of palettes that you need to run a node on your own. So just having these many will let you run a node on your own. Like I said, grandpa is your block finalizer consensus, or is the consensus to start block for finalization. And you have frame system. System is the one that manages the entire node, basically the blockchain node. And then this randomness is just a random palette that you can it has a function that exposes called random. If you want a random number or a random block number, you can use this. But note, this cannot be used in the production environment. Randomness on blockchains work on a different concept. Again, it's out of scope for today's discussion, but yeah, this is
Yes, and
timestamp.
also, can I have multiple palettes within my project?
Yes, yes, you can have multiple palettes. There is no there is no like a cap that you only need to have these many palettes. You can have a number of palettes.
Got
Yeah.
it.
And what's palette timestamp? Timestamp is basically in blockchain, it doesn't work. It doesn't have a time system of its own, right? Everything works on in Polkadot. It's called epochs. Okay, so so that's how it works. So one epoch is defined as a certain number of blocks, right? And it runs for almost 24 hours, and that's how it is defined in Polkadot. So timestamp palette lets you give you a timestamp for any function that is called, or any transaction that is finalized. And then you have the balances. So balances is your accountant. In simple terms, your accountant to transfer funds from one account to another, to receive funds, to lock funds. So yeah, basically that's the thing. So transaction payment. So what is transaction payment? How is it different from this? So this pallet balances is your accountant, and transaction payment is the pallet responsible for the fee calculation for your single transaction. So this is the basically in Ethereum terms, this palette lets you finalize the gas fee for your operation. How much gas or how much transaction fees that you need to pay to do a certain operation on the blockchain, right? That is it. And pallet sudo is basically a super user, right? You have sudo are only accessed by the people who are either mentioned or defined at the council, or those people who are whose account address has been defined as sudo account, and only they can call the sudo and operate on sudo function. So basically, it's like your super user on Linux or even on Windows ecosystem. You run as an administrator, right? So it's your administrator basically.
So Lokesh, I see that I see Aura, Grandpa, Palette Grandpa.
Yeah,
So basically, these are palettes, right?
yeah, these
And
are ballots.
where do these come from?
So all of these come from your frame system palette. So just to observe where these come from, you can look at the toml file. What is the toml file? Toml file is basically the requirements.txt for your Python,
Like in
or
Python,
your package.json in
package.json.
JavaScript. Yeah,
Okay.
something like that. And where you define all the libraries that you're using. And if you look at palette grandpa or aura, you can see that it comes from the GitHub repository substrate. Like I said, it is a frame palette that substrate has provided us for us to use its functionalities, right? So and it has been, so if you see the branch right now, it's the version for use is Polkadot 9.26, right? So I think right now we are at 9.30. And yeah, so this is the main repository that all these palettes are written. These are specifically called as frame palettes because these are out of the box palettes or support functionality that Substrate as a framework offers to people who are coming in. And so since these Grandpa and Aura are part of consensus, you can choose to swap between them and write your own consensus, right?
Okay.
Yeah.
So basically, if I have to add a palette to my runtime,
Yes.
an external palette that is, so
Mhm.
I define it here, correct?
Yes, yes. You come and define it here. So like you can see for palette template is a local dependency, and it's defined from a path because it's there inside my, it's a workspace member under my palettes folder. So
Right.
this is the absolute path or relative path that you provide to your palette, right? And
Okay.
basically all of this is in pace of Rust, so hopefully people are able to at least understand this. If not as well, even if not also, it's basically a package.json or your requirements.txt file. So basically that is what it is, right? And yeah, so Rust also has this concept of features, but yeah, once you move into Rust, you will kind of understand that. But this is where your palettes are being defined. You write your logic inside the palette, and those palettes are imported into your runtime using the cargo toml files in this fashion. And if it is an external thing from the repo, you can always follow this. You can see here it's from Substrate, right? And if you see the name of this package, it's called Node Template Runtime, right? And this in turn, when you come here, so for example, like I said, palette balances. So palette balances has a certain number of config that you need to implement for your runtime, and only then you can use that palette for in your node to run. So these few lines of code is to manage that. So like for example, in palette balances, it needs a max lock variable. It's not a variable, it's a constant. It needs a constant number to define the number of locks that a single account can have. So that is where we have defined it to be 50 here, right? So this is how it you need to implement. So there are multiple things that every palette would need in the config part, which I'm going to show you in detail next. And you define these for config for runtime. And if you see how the palette is imported, you can check at the top of your import statements. Basically these are all your import statements you use. So pub use palette template. So pub is just stands for public, means anybody else within the workspace can also call this. And yeah, and pub use template, this is the import statement basically. And then you have a lot of config like constants that have been defined and all that, but let's not move into that and get confused. But basically the point that needs to be taken away here is that you import your palette, you define the config required for that palette for your own runtime, so that you can use that palette in your node, and then you define it in your construct runtime macro. Rust has this concept of macros. You have attribute macros and you have declarative macros, right? And these are two types of macros. So what are macros? In a brief thing is, these are predefined logic that are that take some parameter to give you a certain output, or run that logic. It's basically a function. But what is the difference between a function and a macro? Macro doesn't need like a runtime to execute. You just it's a long piece of code that can run. Function is smaller pieces of code. And macros, you can define the parameters to be a variable, that you just need the type of it. You don't necessarily need what it needs to hold or anything. But yeah.
Lokesh, coming back to the config part. So basically, when I include a palette to my runtime, I need to
Yeah.
include the config of that palette in my runtime first,
Yes.
and then add it to the construct runtime macro, correct?
Correct. Exactly. Yeah. That is the step. So you
And
define your palette balances config, and then you come and define your construct runtime. That this keyword can be anything. You can name this whatever you want, up to your
okay, that is like the
uh,
name of whatever you want to give, right? Of the
yes,
for the
exactly.
palette. Got it.
Yeah.
Got it.
So this is how palettes are defined at runtime. And let me quickly skip over to the node part, how it is connected here. And if you see here, we saw that here the package name for runtime is node template runtime. And here, if you see, this is the node template, and node template runtime will be imported here. And where is that?
Under
Yeah,
bin.
it's line number 60. You can see node template runtime is in turn imported as a package to your node folder, which holds the main.rs file. And it's imported here, and inside your change spectre rs and everything else, you defined all the config for your node. And then the main.rs is invoked when you run the build command or the start command, and that's what it happens. So this is how runtime is in turn connected to the node. Now let's dive deeply into the main subject of matter, that's our palettes, right? So when it comes to palette, so there are certain things that a palette needs to have if you want to start building a palette, right? The first and foremost step, like you can see here, is like a, a palette that frame or substrate frame provides has a structure or a template structure that everybody needs to follow. Ba- Basically, it's a set of macros that and whatever you see here on the screen, these are the minimum necessary macros that every palette need to have or fulfill, or it must be defined so that that palette works with the logic that you are going to implement for that palette. So we'll come back to this. So more on how these macros, these are called as attribute macros, and in Rust, and how these like I said, macros are predefined logic that takes attributes, and it runs the code in the background, right? You can read more about the palette. There are more attribute macros that you can use for a palette, but we are only going need only these many to actually write a palette. Now let's
So
see how they've done it in
like
the template.
Lokesh, so these are like decorators, right? So
Yes,
which is applied on top of let's say a data structure, and um,
yes,
that uses the functionality within the decorator, like in
correct.
Python.
Yeah.
Okay.
So the way you use it is like a decorator, but these are basically macros which in the background run certain piece of code or logic, right?
Got
And
it.
yeah, like there are certain main things. Like I said, one is palette, the config, the hooks, the call, error, event, and storage. These are the main things that are necessary for your palette. So let's read this piece of code, right? And yeah. So if you can see, the first macro is the palette, where you define. So this is a module. This is a module, and it comes saying that you are decorating this module to say that it needs to follow the palette template that frame support needs to have to write a template. To write a palette. Sorry. Yeah, and moving on, the next main thing is your config, right? So, like I said, there are certain configs, like for palette balances, we spoke about max locks, right? That has to be defined here. And under config, whatever you see is a type. It's not a variable, it's not a constant, it's a type. It can only be a type. Now, this can get really confusing if you read it like this. But now, say max lock, I want to define max locks, right? Max locks is basically a variable of U32. Now U32 on so that will look something like this. Max logs is a get of U32. So if you see here, max logs I'm defining at config, and this is not a like a variable or a constant that I'm defining. I'm just saying the whatever variable or constant that you're going to define for max log has to be of type U32. And here get is basically a getter. It's a wrapper for your U32 so that you can call the constant at runtime once your app is once your application is running, right? So this is how max logs would be defined in the balances. So the main takeaway here under config is that you define the type and the variable, types that are required for your palette to execute at runtime, right? That is about
So
palette config.
is it like an alias location? Like that's what I'm thinking. So like type event is an alias for the type that is after the semicolon, after the colon,
Yes,
right?
yes, yes. Type event is like similar to you could say that it's like an alias for all of the types that this particular event might need to implement.
So basically, when I pass a certain value to
Yeah.
config, it has to
Mhm.
fulfill all the types that are there on the right, correct?
Yes, yes, correct.
Okay, okay, got it.
Yes. So in Rust is a highly type. It's a type-driven system. So every variable, everything in Rust needs to have. Will have a type of its own, and that is why it's like it again provides a lot of security. Moving
Got it.
on, you can see, again, coming to palette, basically this is just a struct or just a definition. So Rust follows this system of traits and trait model, and that where we define struct. We don't have object, uh, I mean, the oops concept here. We don't have classes or such, but we have structs and traits, right? So basically you can assume this is just the name of the class, or this is the main struct palette that we are defining, and that is we are attributing, we are decorating this with the palette macro. So this will enable that okay, now whatever this module is going to be under the palette. So I will use whatever functionalities under this palette through the struct, right? So in a class, what happens is you define a class. Now say you have an animal class. Under the animal class you will define the few parameters that is required for you for the animal to to even create a class, like say for example name and the sound that it makes, right? And then you'll have a function, then you have set of functions, like for example bark is a make sound is a animal class function that any animal can have, right? So similarly you have in comparison terms, you have a struct, and that the name of the struct is your class name, and then the functions that you define for the struct is basically your class functions. And what we are going to do in our palette is basically define certain functions that behave as an extrinsic and also helper to the struct, so that this can be used by others. And this is basically your class functions in comparison, right? And then there's an important macro called palette storage. So what is storage? Storage, if you see here, is of type something. This is the name of the storage, which holds a certain value. For example, U32, right?
Hmm.
So this is basically a data structure. So Substrate provides a certain, few data structures. Most commonly used are storage value, storage map. You have double storage map, and and it does not have vector as such. Okay, vector, array as such, but you do have the vector class or the array class that you can import from frame system. There is a module that you can import, right? So these are different data structures, and here is where you're storing your value. Now, your data storage value stores a single data. When it comes to storage map, it's again a key value pair data structure, right? So it's as simple as that. So again, no need to get too much into the code, but I'm just explaining how these macros play a big role for us to develop a palette, and how simple it is when it comes to develop a palette. All I need to make sure, now we've finished config, we finished this palette, these are all coming in your template. We are not writing any of this. You see, this is a new template that I've just forked, right? If I want to change something, I just need to change the name of my storage, or the value that the type of value that I'm storing. And even in config, I just add my other config that I want, right? So it's very simple as that, but we need to first understand what these are, what these lines of code are. So moving on, you have palette event is basically a the substrate node works on the WebSocket connection. So an event is thrown every time a transaction succeeds. So you don't any function in as a I mean as an extrinsic. What is an extrinsic? Something that can be called by an outside member or a client, right? Does not have a return. You cannot share data back. Instead, you emit events saying that the transaction was completed. And on successful transaction completion, you can share some event, some data inside that event. For example, he's storing some value in this data storage, and once the function is like once it's completed, you throw an event saying that something is stored, and along with the U32 is the value of uh, the number basically that was stored, and the account ID is the person who stored the number. That is about event. And similarly, you have an error and event are of the same thing. Only thing is event throws a successful transaction, error gives you a reason why the function was unsuccessful. So if you see, you have errors such as none and maybe a storage overflow. The data structure they are storing has a max of, say, U32 has a max, right? 2 per U32, that's it, right? So whatever between that range, so if it goes above that, there's an overflow of the time, right? So these are the certain errors that you define. So you define these things, the most event that you want to define at the completion of your function, and the errors that could possibly handle. And then you have palette call. This is the main piece where
Lokesh, may I interrupt?
yeah.
So I see that you have. So the error enum is different from the event enum. I see
Yes.
just words in errors, but in event I see U32 and the account ID. Why are they different?
Yeah, so like I said, in event, basically we share the data. We can share certain piece of data that we have transacted, with the I mean, related to the transaction that was completed. But in error, you just want to give an error message of why the transaction did not happen because you don't have successful data to share. So yeah,
Okay, okay.
yeah. So moving on, like now I've told you like palette is the class name, for example, and like the comparison. And now I need to implement functions, right? So this is where the inbuilt keyword comes in, say you're implementing functions for the palette. Now, for example, this do function, do something is a function. Now, what is the difference between using a regular function and something that is under palette call? So call is a macro that converts any function that is inside this macro to be an extrinsic that can be called by the external client or external software or external people basically, right? So and you can also observe that it has the palette call decorator on it, and also it has another decorator which is the weight. Now what is palette weight? It is basically defines the transaction fees that you have to pay to call something and to call this function do something. So this is basically your gas fees in equivalent of Ethereum, and this is the extrinsic that you're calling. And yeah, and if you see here, we are defining, so do something is a simple function. Basic gist of what it's doing is it makes sure that who is the person who's calling this function. So at the end of this function, you will get an account ID. So let who will be a variable of an account ID, and then your the name of the storage, something that you have defined here, right? You're doing a insertion into the storage. So something dot put and the value. So here you're taking up two parameters. One is the origin that we don't need to break our heads on. Basically, it's your account ID that you're calling, and something is the value that you want to store onto the blockchain, right? This is the blockchain storage. Type something. I mean, this is the blockchain storage. Though this value you're defining at while calling this extrinsic, and that is being in turn being inserted into the storage. And then, like I said, at the end of a successful transaction, you deposit an event, and here you deposit an event saying something is stored, and this is the value that was stored, and this is who actually stored it, right? And it returns on a dispatch result. So let's not get in too deep into this, but then basically you're returning a result that is empty, that you're not actually returning any value to this function, but instead you're throwing a success event here. And if there were errors, you can see there are question marks in Rust. So question mark is basically a what is the syntax sugar, so that if an error is thrown, the code will not execute below that, and that error will in turn be returned. So for example, we have errors that we have defined, storage overflow or things like that, right? That could be something that can happen when something is being inserted, like some value is being inserted into this blockchain storage. So there can be a storage overflow, and that will be handled through this piece of code. So yeah, this is the main thing that I wanted to like tell you, that these are the main macros that a substrate palette is designed at. So all one needs to do is make sure to define and fill this, and you write your custom logic. Now say I want to do my custom thing. Say I want to add two numbers. So I take num1 as a U32 and num2 as another U32. And now I want to store the addition of these two values, right? So now say, let me say, let result is equal to num1 plus num2, and I store the value of result into this, and I want to return an event that is the addition of two numbers, right? So now I have modified this template code for my custom logic, and this is how you want to do it, right? So now I will run the build command here. So how do you run it? It's cargo build, and yeah, it's going to execute for certain time, but yeah. So meanwhile, while it's building, so basically, this is how you write your custom logic for a function that you want, and you change the inputs or the values of your logic. But you see, it's very simple that I changed the entire function. I wrote something new, and it's all template code. The amount of code I've written is just 3 lines, right? So this is where substrate becomes very beginner friendly and user friendly to write your custom logic and build your own blockchain. You don't have to worry about the security. If you are connecting to the relay chain, you're sharing the security of the relay chain, and these palettes are plug and play palettes. You can use n number of palettes, and which can be imported. And you also have so in the developers thing, if you come here, you have something called as marketplace. So when you come to marketplace, you can find custom runtimes that people have exposed, open source, and custom palettes, and also projects that are working on, right? So let's look at palettes. So if you see, there are so many palettes. You can have all palettes. There are accounts. So palette balances, like I mentioned, is an accountant. You have recovery, you have vesting. Vesting is for vesting. Basically, you store money into a mining pool, liquidity pool. And assets, like I said, palette assets let you not only create your own tokens, but you can have data assets, like example, uh, and anything can be an asset. Like say you want to build a land agreement contract on the blockchain, so you would use a pallet assets because the agreement itself is an asset. And again, for consensus, like I said, we have Aura, we have Grandpa, and Babe. These three are by default used by Polkadot, but if you were want to use something different, or you can still use that. And these are again like authority, authorship, offenses, staking. These are different palettes that you can use for your own custom node to provide some sort of consensus and functionality that are exposed. For example, pallet staking lets you gives you a functionality of staking. So you can stake money. So what is staking? You there you have a liquidity pool of people who are putting in their money and clubbing all their money together. And at certain liquid when it reaches the liquidity cap, so this money is returned back to all of the members in the pool. And for being in that pool for such a long time, you get certain rewards, right? So that is how pallet staking works. So you all of you can explore all of these things. And similarly, you have governance palettes. You have democracy, you have election palette, like not Polkadot, your regular elections that can be conducted on the blockchain. And then you have identities, recipe, runtime. You have multiple runtime things that you can talk to. There are runtime APIs. And like I said, Polkadot not only offers you building your own node, like how you build smart contracts on Ethereum, or you write a smart contract on Solana. Polkadot has the palette contracts that can you can use to write smart contracts if you're building your own say a node that needs to have its own contract and like talk to a contract. And palette EVM basically connects to your Ethereum contracts. But apart from this, Substrate also has something called as Ink. Ink is for Substrate smart contract development. So it's an individual contract, like how you write your Solidity contracts or Solana contracts. So that would be a direct comparison to Ink smart contracts on Polkadot. But here, our main thing is Substrate as a framework to build your own node, your own chain, your own DApp, right? Let's just check if it's built. So yeah, it's kind of built. And now let's just start this. Target build.
So do I need to always give origin as the first argument or first parameter to my function?
Origin is something. So I'll show that in the UI right now. So let's get this node started. So this is the start command, target debug node template. So basically it'll be, if you're doing cargo build release, it'll be like in the build folder. I'm not done a build release, so it's just on the debug folder. And so here I just add one more thing, a flag called ws external, so that I can communicate with my other thing. And you can see this build finished with no errors, right? So if this is started, once this thing starts, okay, it seems to be some, yeah. So you can see there is a instance that has been started and it is trying to run the thing. Now you can see best 0, finalized 0. These are the block numbers. And at the moment there are nothing that is started because I am not added the dev flag. So let us quickly stop this and add the dev flag as well. So by doing the dev flag, I tell the template saying that, listen, I don't have a consensus network or a group of blockchain that I'm connected to achieve block finality. So which is why you saw all the three times it was block 0 only, because I don't have validators to finalize my block or a transaction, right? So Polkadot, when you're developing, offers this dev flag that you can offer in such a manner that it automatically finalizes a block. So the code can finalize the block. So even you don't need to be connected to a whole network for block finalization. So now you can see it finished. It started at block number 0, it got finalized, and now it's moving on to your block number 1 and so on, right? So this is how your node template starts. And something that you want to probably want to notice here is when you start your node, right, you have certain details that the node gives. So these hashes, right, this is the hash of your genesis block. Genesis block is basically your first block that was connected on, started on the chain. And similarly every block has its hash, right? And you can find all those details here when you want to like say connect or find the details of that particular block number. And now you can see it's already finalized 8. Now Polkadot also offers something very interesting for us. Okay, guys, I just want to, I haven't saved this file. Let me just save this file and stop this, redo the build command. Yeah. So meanwhile, while this is happening, so Polkadot has something called as the Explorer that you can use. So you have Polkadot JS Explorer that you can open and interact with your blockchain node. So when we started so the reason I rebuilding this is it was not saved earlier, so that's the reason I'm rebuilding it. But once the chain is up and running, it's more on the backend side of things that your node is running. How does one interact with the node, right? So now that is where we want to apply when Polkadot offers something called the Explorer. And here you can see it's connected to multiple things. You have a live, so we are in development. So this is basically my dev environment. Um, right. Let me just save it somewhere and keep for use. Yeah. But yeah, moving on. You can find live networks. So all the actual projects that we spoke of chainx bridge, we spoke of darwinia, there are crust network, you have akala, there's nft mart, there's polka dex is a this one. So all these networks is something that you can explore, and these are running as their own networks or an own chain of their own. And similarly, if you come here, you have Polkadot. If you switch, it's an explorer that I can connect and explore what all the block details are, what Polkadot is offering, and those things. For example, if you see here, you can see last block. I mean, this is the block finalization time, how long a block is taking. Right now, this is the block number that is running. And here, this is the event that was thrown at this block number. So this is the block number, and this is 26 is the number of transaction, or the number, the ID number of the transaction within that block. And this was the I mean the data that was shared in the, I mean, event that was thrown and the data that was shared. So if you see here, result has an error, and there is an error saying that there's a error certain hex value, right? But yeah, so this are, you can see here all these account IDs that you're seeing. These are all the account IDs of the block finalizers. So these, so for example, this block number 812 was finalized by this person called MC parallel whatever, and his account address is here, right? That is what it is. And you can also see, like I said, it's a transparent network, the blockchain. You can see how much of dot he has. Dot is a Polkadot currency. This is the thing, I mean, his total account balance, out of which he's logged one dot, and he's reserved 20 dot, and he's bonded one dot. So we spoke of the bonding functionality that Polkadot offers. And I mean, to ensure that all of them are active and running, and there are no like I mean, useless or like something that is not running or inactive parachains running, right? So that's the concept. You can send dot from one person to another. Another thing I want to showcase is the wallet. So so this is your MetaMask wallet. So similar to MetaMask, you have something called a Polkadot JS uh, apps. So at the moment, so there are multiple I mean wallets that you can connect, but let me also show you the one that I'm currently using is something called Talisman. Talisman is again open source grant funded program that Talisman developers have, and they create an account. So one feature about Talisman is they have connection via multiple chains. You can connect Ethereum accounts, you can connect your Polkadot accounts, you can connect your Solana accounts. All these accounts can be connected into Talisman. And right now, you see, this is a test account that I have created to just to showcase for this session, that I have connected to my Polkadot chain. So right now, if you see, this is my Valaf test, and this is the account ID I'm using. And if you see how much balance I have zero in terms of real life dot, right? And so yeah, this is an explorer basically, and when you go to your network explorer, you find all the block numbers that are being finalized, and you have events that are thrown. For example, there was a balance transfer from this account ID to this account ID, and this was the amount of dot that was transferred between these two accounts, right? So these are all, this is how the data is shared. And when, so similarly, you have staking, parachains and all that, and you have governance modules, like I said, mentioned. We have democracy, we have a council, we have a treasury that maintains funds for certain network operations. Then you have developer. So this is our main tab that we will be focused on today, where I have the extrinsic. I'll come to my extrinsic, and I want to call any of the, for example, like I said, staking. So you can come to the staking palette, the one that I showed in the marketplace, and come and click on bond. Like bond is a function that you can put in some money for the staking palette. But right now this is happening on the live chain. Like I said, I'm connected to the main Polkadot relay chain. You can see the name relay chain written here, right? And yeah, but let's quickly check if our chain is compiled. It's compiled here. And let's start our node. So because if that is connected, so as a developer, I don't need to be connected to a main chain, because you see here the finalizers are account ID. They have a network. But like I said, when we use the dev flag, we don't necessarily have to have a system of, or I mean a network of operators or a validator who is finalizing your main transaction. And you can see it has started, and blocks have been started to generate minus one, because the dev flag automatically generates, finalizes the block, right? And if I now connect to my explorer, you can see that, let's open a new one, right? There are 7 blocks that are finalized. There seems to be some issues with the connection from the Dockerized container to the front end explorer, but let's just
Try in incognito.
uh,
Now change the try changing the link.
mm, the link is correct. Okay. But I believe it's a connection issue from the playground. But as you can see, there was no errors in compilation of the code, and the blocks have reached 21 at the moment. Right?
Can you paste the link in chat, Lokesh? I can try.
Sure, sure. Let me know that. So yeah. But yeah, let's just check it out. If not, we are not able to showcase the Explorer. But like I said, I just want to show you that once you connect it on a chain or a development network, the extrinsic tab is what we are worried about. And our function that we wrote here to add this name would pop up across the uh, tab here. So here you're choosing an account, you choose your account ID, and then you choose the palette name. So this is the name of the palette. So staking here is the name of the palette staking. And bond is a function similar to your add function that the staking palette provides. And now you can try to transact this. You submit the transaction, you pay the transaction fees, and you do that. So right now I'm unable to showcase this piece because there are some issues connecting this, but yeah. Overall, this is the entire overview of how substrate palettes work, and the entire concept of substrate palette, and how the template, how you understand the template, and how you change the functionality on based what you want, right? So yeah, let's just try again one last time, maybe. Okay.
Did it connect?
No, I'm not. Haven't been able to connect. But I believe this is an error with the Dockerized container. Maybe it is not exposing at the right port or something like that.
So these issues are quite common. It's not like it
Yeah,
doesn't. So yeah, there might be some issue with the container, like you said.
correct.
So
But always the start command is same. You can always see the dev flag being used for development thing. And I added a WS external because I have to connect to the playground. But maybe I think I should do it without the external command. Let's just see if it works. Okay, it's still not connecting. But I think this is not a major issue, to be honest. It will connect. Maybe it's just a Dockerized system connection that is failing.
can you show the extrinsics in Polkadot, Lokesh? Um, so it'll be the same way like we have in our chain.
Yeah. Uh, let's just check it. If not, okay, it doesn't look like it's still connecting, but yeah, like they just said, let me just show you the network extensives once again. So whatever palette we wrote, we come to the developer tab, go to the extrinsic, and then you have submit the following extrinsic, right? Here, these are the name of all the palettes that Polkadot has. For example, they have the XCM palette for communication between other parachains. You have vesting, utility, treasury, staking, and all those sort of functions. And you also have balances. Now let's see if I can do a find a balance, right? So see, palette balances is something that I told you that uses that can be used to transfer money from one place to another. So you can see, you can set balance, you can transfer from one destination to another. And yeah, so you have, so these are the functions that the palette exposes. So these are all the extrinsics that we wrote under the palette call macro. So the same add function, you will find the name add here along with the parameters that is required. And this is the name of the palette. And then once you have submitted all the data that is required with along with the parameters, you click on submit transaction. On clicking on submit transaction, you just click on sign and submit along with the wallet connection to your Explorer, and the transaction should succeed, right? So that is basically the overflow of things. But yeah, is there anything else we want to showcase here in terms of palette and Explorer?
Hmm, I think that pretty much covers everything, like an overview. So basically, you can see the balances that is written in the palette section, right?
Yeah.
That is the name that you gave in your construct runtime,
Yes.
uh, and this is how it appears when you select individual palettes or respective palettes.
Correct. So this is balances is the name that was defined. So that's the name that you will see here as a palette name, and these are the functions. Correct. Yeah. So this is the brief introduction to Polkadot and substrate palettes. I hope you guys enjoyed the session. But yeah, so the last point that we wanted to cover is basically our Polkadot India, yeah, community that we have. And Tejas, you want to shed some light?
Sure, sure. So Polkadot India is basically an initiative in India. We are here to spread the message of Polkadot that you can have smart chains can communicate with each other, make it completely interoperable, and have total freedom and flexibility. In creating your own custom chains with your own custom logic, um, and um, hack away whatever functionalities you want to include in your chain and make it as far fetched as possible or as reachable as possible. So,
Yes.
so we do conduct a lot of offline events. If
Yeah.
you can show that, yeah,
So if you see, this is an offline event that happened in September last month. This I mean, so we have offline events happening all across India. I mean, we have Chennai, Mumbai, Delhi, Bangalore, and all that. So we, apart from this, we also conduct boot camps for developers to come in and learn. And obviously, you will be, so in the boot camps you also have placements. But then again, it depends on the assignments that are shared and on timely and justified completion of the assignments, right? So. Yeah, this is a small glimpse of what happened with our offline meet. And we also have a lot of founders of within the Polkadot ecosystem that are building their own dApps or products using the Polkadot system. Yeah. And
we'll keep the screen for like 15 seconds and
yeah, you can scan the barcode to join our Polkadot India community. And I guess that's it from our end, guys.
yep,
I hope
Yeah, thank
this
you.
was overwhelming enough for everybody.
hopefully not.
Thank you so much, guys,
Uh,
for doing this. It was a pleasure having you. Got a lot of answers for me. Thank you very much.